everyone has a piece of paper with a pencil and eraser
Are you going to take a picture?
and pen. Yeah, sure. And now, please, Elvis.
So,
Guys, please everyone
guys,
listen.
listen carefully.
Elvis. Guys, Elvis is going to talk about today. Today we talked about the partial derivatives, and I should say coincidentally, which is favorably, Elvis is going to talk about the differential equations. One of the most, I should say, core concepts of the math, which you're going to have with, let's say, in advanced degrees, I should say, with the differential equations. He's going to talk about the ordinary differential equations, not the partial differential equations, which is going to be, I should say, one of the main hot topics for the research when you just go higher in, I should say, your studies and university. And now, Elvis, please, the scene is all yours.
Okay, so today I want to talk about the differential equation in calculus. So this picture is my family. This is my brother, my father, and my mom. So
Where is that picture taken?
in China, the south of China, in Jiangxi, Lushan. Yeah, this is it's a very famous mountain.
Oh, really?
The rainbow under the rain. No, the waterfall. On the waterfall.
Oh, interesting.
他妈的闭嘴 ！Shut up. Okay, so next page. So this is the concept. A differential equation is a mathematical equation that describes the relationship between a certain type of function and its derivative. The solution of the differential equation is a function that fits the equation in algebraic equation of the elementary mathematics, and the solution is constant values. So this is a very deep concept of the differential equation. We will learn it in the university. So today I only want to talk about the basic or the things that we need to know to do the question from the books for our trial grades. Yeah. So next page. Okay.
Sure.
So analyze there's some 6 analyze there. So next page has 3 too. So generally, real world differential equations are not directly solvable. You will know that in maybe 2 page. Yeah. So I will give you some examples. So and that's when we use the numerical approximations. Yeah. This is only some concept or the analysis, and we are going to look some simple ones to get a better understanding of the differential equation themselves. Yeah, so next page. Okay, so the differential equation contains the derivatives of unknown functions. I will tell you later, and you should know this the number 4 and the number 6. You should remember it. And I will explain to you. And so the 5 is give some simple differential equation we can sometimes guess at the form of the function. And the most important one is we will work backwards from the solution to the differential equation. It means this is most important. Why? Because in many questions or the question from books, it will tell us the differential equation and tell us, and they ask us the solution and they will tell us the solutions and the differential equation. So and it will say, please prove that it is correct. Yeah. So the next page. Okay.
Wow, that's very beautiful.
Yeah. So it is very make you very confused because it is a very difficult concept of the differential equation because I will explain to you. So I will use the blackboard.
The blackboard? Yeah, sure.
you can see this one. You know this one? You know. So this is the derivative.
The first derivative.
Yeah, the first derivative. And the first derivative is.
Then bring you another mark here, the black one, which is going to be much easier to see that. Give me 1 second. You got it. There you are. 2 colors. No problem. Start? Yes.
Can I go through what?
Yeah, sure. But be back quick that we do not miss this beautiful stuff.
So you can see the
You guys, listen. Listen, please.
So this one is, you can see dy over dx equal to, so it is same as fx. So this derivative, yeah. And so the next one is, I will tell you. So you may feel a little bit confused because we don't know why. I'll tell I'll tell you this is equal to.
Fx.
And I can write it another way, so you can write.
What is y squared?
So do you know this one? This is means this is the derivative. This is the derivatives of derivatives.
So true. The second derivative.
In my word,
That's
derivative
right.
of
That's so true. The derivative of the privative.
为什么
Yeah.
上面有个 d 有一个 square？
Huh?
不是你写的。
You mean this one?
Oh.
Yeah. Let me tell you. Okay, so you can see dy over dx equal to fx. And okay, so how about this one? It means it equal to dy dx times. So this is okay. D f x dx.
Great.
So you can see. Okay. So this.
Sometimes it's better not to just have this one. When you just want to, for example, explain that.
Yeah.
It's sometimes good to say that, for example, this one becomes the derivative d over dx. We can skip the y.
Yeah.
Then you have a parenthesis, say of d of dx of f of x. Then that's essentially that's the thing. Then that's what you mean then. That's right. But I include just a parenthesis to show that this one acts on the another derivative.
Yeah. It's true. So no.
我看不懂啊这个。
So beautiful.
Yeah. So this is equal to
One. That's right. Super.
So this is and then if you have more derivatives, you will get this and this. You can this one dn times y over d times x. Yeah, n. So this is the derivative of this one.
This is actually it's a kind of a chain.
Yeah,
For
it's
example,
kind of change.
that's right. For example,
Yeah.
that's what I should say. Elvis is saying is that, for example, look at this. You say d, for example, instead of the n, imagine d fifth of dx5 of the y.
Yeah.
It means what? It means that you're taking the derivative of the fourth derivative.
Yeah.
The fourth derivative is a derivative of the previous
Yeah.
derivative. It's like the steps. Look at that. Steps on the staircase. You go up there. For example, this is the first derivative. From the first, you go to the second, to the next step. From the second, you go to the third step. From the third, you go to the fourth step. It's like the staircase.
Yeah.
Each derivative is
Yeah.
built on the previous one.
Yes, yes.
For example, the 1,000 derivative of a function, which is always differentiable, it's built on the 999th derivative,
Yeah.
which you made before that.
Okay.
Huh?
Yeah.
Super.
Okay.
Gonna
So do you know that one? So are you clear?
Fine. Guys, did you got it?
You got it.
That was great. Thanks. I saw a Bessel function there. It just made me wow. Amazing. Bessel function. It's very, very beautiful.
This is from Wiki. Yeah. And so the ordinary differential equation is the derivative. So this example, this is very famous. This is called Bessel's function. So this is Bessel function. This is also this is the differential equation. So this one. And you can see this one, and I will tell you, in our books, you can see this kind of questions. So I will tell you how to solve it.
Give me 1 second. I want to take a note of that beautiful function, the Bessel function there. I'm gonna work with that later.
Okay, I can send it to you.
Oh, yeah. Sure. The Bessel function. Yeah, please. Here.
Okay.
Oh, guys, that was the best Saturday ever. That was the best Saturday ever because in the morning we learned the partial derivatives, and now when we are learning the ordinary differential equations, we see a very interesting function, the Bessel functions. I'm going to give you a homework essentially based on the Bessel functions, but we just put it for the next week then. But please everyone, look at this function and remember the name, Bessel function. It's one of the most interesting functions in the, I should say, the ordinary differential equations. We're going to talk about that more. Thanks a lot, Elvis, for just bringing this up.
Okay. So next page, please.
Yeah, sure.
And the second one is called partial. The first one is ordinary. So the second one is partial differential equations. This is called PDE. Yeah.
Guys, please listen. What that's essentially.
So and fortunately we learned it on the morning class. Yeah.
That's right. It was very good.
So yeah. So this is that one is fxy. Yeah. Do you remember?
We had it today, guys, in the morning.
So I'll tell you. So sorry. I will tell BKE.
Let me erase these forward.
Okay.
Please.
Thank you.
Guys, this is very fortunate that we learned about the partial derivatives, and now we have partial differential equations.
So in the morning we learned it. So because if there is maybe x is one, it use this code.
Delta?
Yeah. Oh, today no, let me remember. Sorry. Oh no, this one. Fx
Plus delta x?
Yeah.
That's what you mean?
The other one use.
That's what we did. We said that f prime of the x is equal to f x plus delta x.
Yeah.
That's what you mean?
No, I mean use. So the fxy use this one. The fx use.
Oh, for the two derivatives.
Oh, use d. Oh, use d. So okay.
Oh yeah, I could have used the definition.
Yeah, just. So because in this case we use d. So in this case we use these things. This. I don't know how to
Row.
row. This is row. Use row.
Means partial derivatives.
Yeah, so after using this one, we can easily to define this is this kind of equation or this kind of equation or function. Yeah.
Super.
Okay.
Super.
So and let me tell you a very simple differential equation. And then after this page, I will tell you a difficult one. So this one is dy over dx equal to sine x. Yeah, you know. So the y. So at this time, I will tell you the equation, and you should tell me the solution, the answer of the ordinary function, the function. So you know the differential equation have many different kinds of have many different answers. So you can see y equal to negative cosine x plus 6 because oh sorry
吓死我了！让气象那个
that's it
吓死我了。
Okay, we can see y equal to negative cosine x times c. So what's the derivative of this one? So this one is y equal to sine x. Because c is number, for example 2, 4, 5, 6. So this is 0. So times part 0. So this is sine x. So this is this one. So because in most of the question about differential equation is they will tell you the derivatives first and ask you to back to the original equation.
That's
Yeah, like I said that in the analyze the number 6. I said that one is the most important.
That's right. And guys, this is I should say this example there, which BK and Lee, that Elvis solved it. It's a very interesting one, but in order to see how to solve the differential equations, you need more understanding of rigorous math, which is called antiderivatives, which it means that, for example, from the function, look at that, it's a kind of a loop. You say that, for example, the derivative is like that. It transforms, for example, look at that. For example, look at that. That's an apple. Huh? That's an apple. And that's an orange there. Huh? The derivative which you have learned is a kind of a transformation. For example, it's a kind of a suit and the tie. You're going to go to a party. You are, for example, Elvis. You bring your suit and tie. You transform yourself into some different appearance. Derivatives like that. The derivatives takes the function from being apple to be like an orange. It transforms it. But sometimes you take the steps back. You have been at the orange as a kind of a transformation, as a derivative. You want to go back to the apple itself. That's called antiderivative or integrals or integration. You say differentiation, transformation from the apple to the orange, but sometimes you are from the orange itself. As a result of that transformation, you want to go back to the original state. You have your suit and tie. You want to take that suit and tie off to work in pyjama at home. And that's called that integration. You either have it in the advanced calculus, if the school offers it, or maybe at the first year of the university. Thanks.
Okay, thank you.
我给你干了。
So this example, the y, this is y. So if x equal to pi, so this equal to 2, so we can solve it c equal to 1. If we put 2 pi over there, no, I mean, so this is if we put any x is vary. So you can put whatever you want. You can put pi over 2. Maybe if you want, you can use it. And if the question says y equal to f pi equal to 2, you have to put pi inside and plus c equal to 2, so you can solve c equal to 1. But in some questions, they will not tell you this one, so you can.
That's right.
Yeah, you can solve it. So you will see the answer is various.
And if you don't mind, just jump in a second, guys. Please listen. That's a very important thing.
Yeah.
I'm sure this one you will see that for the rest of your life in any math course which you take.
Yes.
And that's essentially is that they call that initial value problem. Initial means what? Means something at the very beginning. I just want to put in parentheses that the language of the nature, whatever you see from the astronomy to the biology to the economics, everything in nature, it has a language. For example, you speak English right now.
Yeah.
The language for the nature to speak to you is a differential equation.
Yeah.
It shows that how the things evolves in time. For example, how the bacteria, for example, the population changes over time. How, for example, the Earth rotates around the sun. Those kind of stuff. The things which changes with respect to the time in nature. The language is differential equation. But when you solve a differential equation, when you get the constant, you have to know what is the initial value problem. You have to specify where and when the system starts to evolve. Then you start from there to analyze the rest of, of the dynamical system. That's what the Elvis is actually saying in a very, professional way. Thanks, Elvis, for that. It's essentially the initial value problem. You speak this is the language of the nature. It describes some evolution in time. You solve it, you get the constant. But you have to specify where do you start and tell you, okay, when x is equal to pi, the system starts at 2, for example, and that's the initial value problem. Then you know that if you just put the pi equal to x, then you have to get c. It becomes equation of what? Just like that thing. They say when x is pi, the value of the y is 2. You put pi equal to x to pi, it becomes what cosine of the pi? -1.
Yeah.
-1 times -1 plus 1. Then you have 1 plus c equals to 2. Then c you get 1. Then now, from this stage, which was a generalized format of a differential equations, you get specifically this equation based on the initial value problem. That the dynamics of the system starts from at this point. And it gives you more, precision and concise approach in describing the dynamics. Thanks.
Well, thank you.
Thank you, Elvis. It's great. I'm very impressed. Oh, I was going to follow up.
Okay, so next page, please. So, and you will learn, maybe you learned it in the university, and I will tell you the 3 examples. But there are many examples, maybe 6 or 7, but I will tell you 3. So, the first one is maybe the English is the English is very difficult, but you can see this kind of is a differential equation, and this one also differential equation, also this one. So and if you see du dx minus somewhat, for example, yx, xy equal to 0. So you should know that this is a differential equation. Yeah. So and this kind of, because you can see we can put it to the left.
That's right.
And minus x equal to 0. Yeah.
That's right. Essentially, you mean that when you rearrange the dk, all the terms, take all the terms to the other side. One side becomes 0.
It becomes 0.
In terminology in science, they call that this is homogeneous.
Yeah. And you have to have the derivative.
That's right.
Maybe derivative what?
Second
this
order.
This kind of things.
That's so true.
Yeah.
Normally, for the differential equations, the highest level, of the derivative, it defines the order, Michael. and Tony, the order of the derivative, the differential equation. For example, this one, the highest order of the derivative was the second derivative.
Yeah.
We call that the second order.
Yeah.
This one, the highest one, is the first derivative. We call that first order, non-linear
order,
differential equations.
Mm-hmm.
I'm so impressed, man. That's a
Thank
great
you.
job. Thanks.
Okay, next page.
It's very impressive, man. Super.
So, I will tell you about knowledge from the books, and you can solve it. You can solve the question from the grade 12. Yeah. So from the calculus for you, page 242, we are just learning a little bit about differential equations because it says you will learn it in the future in the university or college. Yeah. So so this one is I said before on the blackboard. Yeah, this one. Yeah. So this is the concept from the. From the solution to the differential equation, ordinary equation to derivative to the derivative of the derivatives. So this is the ordinary one. So so this is means fx equals fx and then fx then fx. Yeah. So this is what I mean in this, and the new rules is from the back to you should know what is f. You should know the original one.
That's a kind of an antiderivative.
Yeah.
Transformation backwards to the original function.
It says derivative of derivatives, derivative to derivatives.
That's right.
To ordinary equation.
Yeah, that's so true. Okay, please, next page. Yeah, sure.
So this is a question from our book. Yeah. Oh.
It's a very good question on the book, guys. Maybe it should be on your test. Who knows?
Yeah.
Just learn it down. Maybe on the final test you have it.
So you can see this one is it says a differential equation is this is the concept and determine whether the function y equal to pi sine x sine theta times 2 pi cosine is a solution to the differential equation. I said at the beginning of my presentation. I said you will meet it and prove that this is a differential equation. So you can see I will show it to you. So and we should write it first. D derivatives equal to negative y. You know this clear? Is it clear that just put y over there?
Yeah.
Yeah. So and you can see this, and this is the original one. So this is y. This you can see y, and we made it y equal to pi sine theta. You know this. Okay, and we solve it. Pi plus minus 2 pi sine. So what is this called?
Theta.
Theta.
It's like the I should say Greek letter. They call that
This is called theta?
theta.
Okay, theta. So this is the pi times cosine theta 2 sine. And then And I tell you, this one is what? Ask you, student, you should answer my question. What is this?
Don't answer, I will kill you.
What is this? What is this?
The second derivative, huh?
This is second derivative. Yeah. So and we write what there or there.
Double prime.
Yeah,
They call that double prime.
Yeah. So and then it means
Wow.
okay then. So you can see, and this equal to what? Equal to negative sine plus. Maybe I should write pi before sine. You can see at the beginning. So this is the y. So this is same. It's different. This is the only difference drawing maybe.
That's right.
Writing, different writing. So you can see this equal to this one. So what about the negative y equal to negative pi sine theta minus 2 cosine theta. You can see. So
It's plus.
oh sorry. So you can see these two are equal. They are equal to each other. They are same. So it is true that y equal pi sine theta times plus 2 pi cosine theta is a solution to the differential equation. So do you know that? If you don't know, I can explain it in Chinese to them, maybe if they want. Do you know?
Yes.
Okay.
Let me say that. Let me explain that because they may have it on the test. Let me make sure that they understand it, guys. Look at that. You may have this on the test for the final exam because that's very crucial. Look at that. Thanks for just having the picture of it because it makes it very interesting. Guys, look at that. You have two things right now. You have the differential equation. And as Elvis taught us today, the differential equation, that's an equation which involves the derivative of a function.
Yeah.
And we know that this function, you want to see if this function fits this differential equation. What does it mean? It means that what? It means that the second derivative of the y with respect to the theta plus the function itself, it equals to 0. And also you know the function. Then what is a wise thing to do when you just want to see if that function fits that equation? It means that you take this function, put it inside. If we get to the 0, then it means that the function is a solution of differential equation. Yes, Elvis?
Yes.
We have y there. As Elvis taught us today, the second derivative of the y with respect to the theta involves 2 times derivative. Huh? Elvis said y here, y prime. It becomes the derivative of this function with respect to the theta becomes pi cosine theta plus minus 2 pi sine theta. We learned the rules maybe 3 months ago.
Yeah.
And the second derivative Elvis taught us today is the derivative of the previous derivative. Then the second derivative is the derivative of the first derivative of this function, which Elvis wanted to be this one here. And look at that. We have 2 options to do. Elvis took y to the other side. The function is like this. It means that the second derivative of the function with respect to theta equals the minus of the same function.
Yeah.
The second derivative is this. And Elvis compares this one to the function itself. Look at that. This is y. This is minus y.
Yeah.
Then you see that. Then you fit the function inside the function. Or you can also do the same thing. You say that, okay, I'm not going to take y to the other side.
Yeah.
I'm going to fit everything there to see if I get to the 0.
If you want. Yeah.
That's right. You get the second derivative, it becomes this. You plus it with the y, then everything cancels each other. Then you get to the zero then. Then essentially, as a final rule is that the derivative of a function, if you have it on the test, if you want to make sure that the function fits the functional, I should say the derivative, the differential equation, you take the function inside, take the derivatives, simplify that, see if you get the zero. Yes, am I right, Elvis?
Yeah.
Sure, good job. I'm really impressed. I'm really impressed. Thanks.
And we have another question. Question 2. So sir, please next. So determine a function that satisfies the differential equation D. So this one. What this means? And I tell you for at the beginning of my presentation, I tell you if you have if you have many answers, maybe 100 and many, so you can do it whatever you want. You can fit whatever the answer you want inside. So but it should be correct. Let me solve it to you. So you can see this one is so it is right. So this one is so and because we know this one and we should know what is this one. So this one is equal to, because this is negative 4y, so it is negative 2y square. Yeah. So okay. So and then we know this one, and because you can see this is y, so we should know what is y. So y equal to, and you can see this is square. This is 2. So the y in y, the y is 3. Yeah. 2. So do you know this? Yeah, you can see y equal to negative. So yeah. So actually.
让我研究啊。
So you can see. Maybe I should write. Maybe I should write fx to make you not confused.
这是还我3乘 y 还是3乘 y？ 没法没有信息。那为什么它多了一个不一样？我原来是乘啊。你为什么一还是飘？为什么用3分之一？对，有点3/2 往上看看。因为你没有格子，你直接凑不出来。
You know, this is 3. So and in the derivative it is 3y 3. If the derivative is 3y square.
那为什么中间多了一个 v 啊？你不是 v 那乘
This is times.
哦，你画一个点就得了，这样不用写了。
Guys, did you get it?
You get it?
哦。
Essentially, these type of financial equations, when you do the advanced calculus, you see that they are exponential functions.
Yeah, and maybe you can use sine or cosine, and I will tell you some very easy
That's right.
method to solve this kind of.
That's so true. But also look at that, what Elvis has done, he just decided to say that, okay, if the function you start with that is this, then when you start moving backwards, you get the second derivative becomes minus 4y.
Yeah.
And it fits that equation. Yes, Michael?
Yes.
Yes, Jake?
Yeah.
Thanks, Elvis.
And let's write, so you can see this is equal to negative 4y. So let's do it.
分也好玩讲，多久几个跨度，会有5个，大概应该也差不多好久的天吧。Elvis，你还有几个呀
？This last one.
哦，那就包括大半，讲完就结束了是吧？那可能爬一到我就这样，讲完了而且是好几天。然后打跑回来了。
That's correct. Yeah. So. This is only one kind of solution, and I will tell you, let's solve it by sign.
你为什么盯着我说好恐怖呢？
我就跟老师说。
我是说，这个也是。
So, it is. Do you know? Do you understand? Yeah. Okay. So you can see in many cases, you know, if we use sine 2, you can see, this one is equal to cosine 2 times 2. No, 2x. Yeah, 2x may make you not confused. Okay.
Oh yes. It's bad.
This one, because this is 4, so you should know that if there is 4, which one square is equal to 4? Of course 2. So we use 2. Use 2x, and then cosine 2x times 2.
Next derivative.
That's right. Guys, you can see that if you, for example, choose the y of x, sine of 2x,
Yeah.
2 times derivative of that is equal to the minus 4 times of the same function, which is sine 2x.
So if you see there is a negative 4 over there, so you should know, because the derivative of sine x is cosine x, but the derivative of cosine x is negative sine x. So negative times a positive equal to negative. Yeah, so this is negative 4. So you can see this is negative 4 sine 2x, right? So sine 2x equal to y. So d 2y to dx 2 equal to negative 4 y.
It's still true. Fantastic.
Okay.
Next slide. Or... Oh, okay, please.
Yeah. So that's it. So next page. Okay. Thank you for listening.
Good job. Please listen. Thank you very much, Elvis. It was, I should say, very impressive, because guys, you will see that. I don't know. It's Elvis. Can stand still here. Guys, you will see that in future if the school offers, I should say, advanced calculus, or if you just go, let's say, to higher level math, the grade 1, year 1 or year 2, when you see, I should say, the ordinary differential equation, you will see that they describe the dynamics of the system which they evolve in time. Then solving the differential equations or finding a method to approximate the numerical solutions for that is the cornerstone to analyze any dynamical systems, meaning any systems which changes with respect to the time. Then I hope that today you remember that concept for the rest of your life, and I should say this today, which is February 15, Saturday of 2020, it's a kind of a mark of your, I should say, your lessons this year, that the ODE differential equations are one of the most important things in the math, differential calculus, and concepts which describes the dynamics of the system. And please remember today, February 15, 2020, you learn differential equations, which is going to play a huge role in your, I should say, future studies then. And thank you, Elvis, for that. It was a great session. It requires lots of work for differential equations. Thanks a lot. Anyone has any questions for Elvis?
And you will learn some more details in university.
Higher years, that's right. Any questions for Elvis? No? Then guys, thank you very much. And let me